Welcome back. Here we go. I've been asked to do a joke for you, and a disclaimer. This is, you can fast forward to 15, 20 seconds if you don't want to hear my funny joke. So nobody got hurt in the joke. It's just a joke. It's just a silly joke, right? Just a silly joke. So I was super happy that my wife missed me until she reloaded. Whoa! Just kidding. It's a joke. It's a joke. Okay, here we go. We're on 26 right now. We got a factor the top and factor the bottom. Bottom's already, we got a factor the top and the bottom. So when we factor the top, we get 6. We get 2 and 3. Factors of 2 and 3, we got x and x. Sign of middle term goes with a bigger number. Positive 3 and a negative 2. X squared minus 1 factors into x minus 1 and x plus 1. Yeah. Anybody want to say anything back there? Say hi. Say what's up. Okay, here we go. So, oh, they already did all the information for you. You just have to graph it. Just have to graph it. So we have domain at 1 and negative 1, vertical asymptotes at 1 and negative 1. So we're going to go ahead and graph it now. Ah, wrong one. So 1 and negative 1, right? Vertical asymptotes. So x equals negative 1, x equals positive 1, vertical toads, vertical toads. Nice. Okay, we have a y-intercept. We have a y-intercept. We got a y-intercept. We got a y-intercept at 0 up 6. 1, 2, 3, 4, 5, 6. There's our y-intercept. We've got an x-intercept at both negative 3, 1, 2, negative 3, and 2. 1, 2. It's kind of odd. In fact, because of the both odd and cross. Sure. They're both odd and cross through. Good. Let's see here. So end behavior. We got a horizontal asymptote at y equals 1. And the reason why, do you know why it's 1? Do you know why the horizontal asymptote is 1? Do you guys know why it's 1? Horizontal asymptote is 1? Because the powers are the same, and so you use the numbers in front. Use the numbers in front. That's why it's 1 over 1 equals 1. Okay, there we go. Okay, so how do we graph this guy, right? So we are going to graph this using the horizontal and vertical asymptote. We're in the bottom left quadrant, bottom left. So we're going to go along the asymptotes and then cross through at the x-intercept and go along the other asymptotes. Always let the toads be your guide. Jiminy Cricket. Always let your conscience be your guide. And x-intercepts and y-intercepts. On this side, we're going this way because the x-intercept is below. The x-intercept is below. So we go where the x-intercept is. Along the asymptote, along the asymptote. Now the tricky part is the one way up here, right? Tricky part is the one way up there. Well, let's see. Our vertical asymptotes are odd and they're odd. Interesting. Both odd. So what does odd mean? Odd means opposite direction. So we're going down, and then we're also going up, crossing through the y-intercept. I feel like this should be both going up. Okay, let's try it. So that's going up. Okay, I think I got it. I think I got it. So this is going down, and then up. And this one is going down. So that means after this vertical asymptote, we have to go what? What? We have to go up, right? And so we're looking at the vertical asymptote to know what the end behavior is, going down then up. Right, Jack? Going down. Name drop. You're immortalized now. As long as I don't show your picture, we're okay. As long as we don't show your picture, they don't know who. They don't know who. So down, down then up, right? Down then up, down then up. And the reason why is the vertical asymptotes are both odd. And so that means down then up. Or it could mean up then down. Because it's after the vertical It's after the vertical asymptote where you do the down and up thing. Okay, there we go. So there's number 26 graph. We did a good job there. So then we're going to jump over to, remember it goes like this. Up there. It goes up, up, up there. Or it goes down, up, and then up, down. There's a y-intercept is 0, 6. Yeah. Okay, next one. Yeah, 27. Let's go. So we got to factor this, you guys. So factors of 15. Factors of 15 are. Pause me. Hey, you behind the screen. I know you're watching. You better pause me and try it on your own first. And then push play and see how you did. Then push play and see how you did. So 3 and 15. They both have to be negative. This is x and x. 1 and 5. And so how do we get a 5 and a 1? Let's see. Well, 5x if it's negative, 5x with a negative 1x, that gives us negative 6x. Wayo, we got it. So then the thing that cancels is called the whole. The thing that cancels is called the whole. So x equals 0. No. X equals what? X equals not a negative 5, but a positive 5. So there's the whole, there's the whole. Good. Okay, so what's our reduced function then? We have x minus 1 over x minus 3. The domain restrictions though, what are the domain restrictions? So the domain restrictions are positive 3 and positive 5. The thing that doesn't cancel is the vertical asymptote. So that's the 3. So now we have a vertical asymptote at 3. Vertical asymptote at x equals 3. And how do we find the y value of the whole? How do we find the y value of the whole? Right? So how we find the y value of the whole is you take that 5 and you plug it into the reduced. Plug into reduced. And that's how you find the y value of the whole. To find y value of the whole. Okay, so we plug a 5 in there. So 5 minus 1 is 4. And 5 minus 3 is 2. And 4 divided by 2 is 2. So that's the y value of the whole. So over 5, 1, 2, 3, 4, 5, up 2 is the y value of the whole. The x-intercept, you have to set the top equal to 0. Set the top equal to 0 for the x-intercept. And so you also have to set y equal to 0, set y equal to 0, but also the top equal to 0. And so the top is, what's the top? What's the top? So the top is x minus 1 equal to 0. We're going to add it to the other side. So the top equal to 0. So that's x minus 1. Let's do it in green. So we set the top equal to 0. Set the top equal to 0. So we add 1 to the other side. So we get x equals 1. So that's the x-intercept. We have an x-intercept at 1, comma 0. And then the y-intercept. How do we find the y-intercept? So to find the y-intercept, you set x equal to 0. And so our function is y equals 0 minus 1. Right? It's x minus 1 over x minus 3. But we're setting x equal to 0, 0. And 0 minus 1 is just a negative 1. And 0 minus 3 is a negative 3. So we get 1/3 for the y-intercept. And so we have to set x equal to 0. So the y-intercept is 0, comma 1/3. So we go 0, 1/3 is our y-intercept. That's our y-intercept. So 1/3 is our y-intercept. And all we need now is the end behavior. So, Mr. Newbold, so top is equal to bottom. What does that mean? Let's see. Oh, so we have a vertical asymptote. We need to find the horizontal now, right? Because top is not greater than bottom. Top and bottom are equal to each other, right? So since the top is equal to the bottom, right? So we're not going to do any behavior. We're going to do horizontal asymptotes. And since we have x squared, dot, 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 over x squared, dot, 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 from here and here. And since the powers are the same, we're going to use the numbers in front. Invisible 1, invisible 1. And so y equals 1 over 1, which is a 1. And so that's going to be a horizontal asymptote at y equals 1. And now we're going to graph it. And so to graph it, we're going to go ahead and go along the asymptotes, through the y-intercept, through the x-intercept, and along the other asymptotes. And then is it up, up, or down, up? Well, we look at our vertical asymptote, and there's a power of 1. And that power of 1 is odd, so we're going to go ahead and go down, up for graphing purposes. For graphing purposes. So now we're going to go ahead and go down and then up. Down and then up. And then we'll go along our hole and skip over our hole. There we go. There's number 27. Way-oh, number 27. And then number 28. We'll do number 28 next. So number 28, it's already factored for you. There'll be one of those on the test, maybe. And so the x minus 1s are going to factor. That's called the whole. At x equals 1, it's called the whole. The reduced function is going to be 2 over x plus 1 all squared. Right? So how do we find the y value of the whole? The y value of the whole. So we go ahead and take the x value and plug it in. So 2 over 1 plus 1 all squared. Where we're using the x value of the whole, the x value of the whole. And so 2 divided by 1 plus 1 is 2. 2 squared is 4, which is a half. So we have the y value of the half. So we have 1 comma half for the whole. So we're going to go over 1, up a half is where our whole is. Our domain restrictions are x can equal 1 and negative 1. The vertical asymptote is what's left. And so that's going to be negative 1, opposite sign, opposite sign. So we have a vertical asymptote at negative 1. Good. And then to find the x-intercept, you set the top equal to 0. Find the x-intercept, you set the top equal to 0. But when you do, when you set the top equal to 0, that doesn't exist. Yeah, it doesn't even work. So there is none. Because 2 to 2 does not equal 0. And it's probably because there's a horizontal asymptote along the x-intercept, along the x-axis. Right? Let's find the y-intercept first. So we set x equal to 0. So y equals 2 over x plus 1 all squared. We plug a 0 in there for x. And we get 2 over 1 squared, which is just 2 over 1, which is just a 2. So we have a y-intercept. We set x equal to 0. And then comma 2. So we have the y-intercept at 0, 2. And then our end behavior. Well, we have a vertical asymptote, so we probably have a horizontal. Look at the powers. And so our powers, oh, that's weird. So our powers, technically, there is no power. Where's the power? Where's the power? Yeah, there's no power there. So technically there is. Technically there is. Right? Technically there is. It's some x to the 0 power. Because anything to the 0 power, even x, anything to the 0 power is a 1. So technically there is an x there. There is an x there technically. And so now we have x squared. And so top is less than bottom. So top is less than bottom. What's that also mean? It also means Bobo. So Bobo means bigger on bottom. Bobo means bigger on bottom, y equals 0. So that makes sense now. We have a horizontal asymptote at y equals 0 along the x-axis. And that's why there's no x-intercept, because there's a horizontal asymptote there. Sometimes we do, but not on this one. There we go. So now we can graph it. We got all the parts. Now we can graph it. So we're going to go along this asymptote, cross through the y-intercept and the hole. So your asymptotes guide you where the graph goes, and so do the x-intercept and y-intercept and the hole. And so then we got to look at the, whatchamacallit? We got to look at the vertical asymptote and see if it's odd or if it's even about the asymptote, about the vertical asymptote. So let's take a look there. Oh, it's even. Whoa, it's even. So since our asymptote is a 2, so it's x plus 1 to the second power. That's what you look at. The power, is it 1 or 2? And since it's 2, that's even. So even means the right side is already up. The left side needs to be up. Up, up. So that means we're going to come along here, and along here. And there's our graph. There's our graph. Now, if you don't believe us, go to y equals. We'll turn this one off. And we'll just type it in and see if we got it right. So lots of parentheses, you guys. Lots of parentheses. X minus 1. Lots of parentheses if you're putting your graphic calculator. Divided by. Lots of parentheses, guys. X minus 1, close parenthesis. X plus 1 all squared, close parenthesis. Lots of parentheses. Okay, let's see if we did it right, you guys. Let's see if we did it right. 3, 2, 1. Boom. And that did not work. Zoom 6. Woo! Yeah, woo! Woo! Yeah, look at that. There's our graph. We did it right. Woo! Let's give ourselves a hand. Woo! Yeah. Woo! All right, stay tuned to the next video where we will be doing the rest of the practice test. See you soon. Bye for now.